Welcome back to my YouTube channel. In this video, let us discuss something about superposition theorem. So in the examination, they will ask you the statement and explanation of superposition theorem. Along with that, I'll explain one more simple problem from superposition theorem. You can easily understand like how to solve the superposition theorem, a step-by-step procedure by taking a simple problem. Okay. So now we can see the superposition theorem, which states that you can see here in any linear circuit containing multiple independent sources, which means that more than one independent sources, either it may be current or voltage, so that you can see in any linear circuit containing multiple independent sources, the current or voltage at any point in the network may be calculated as algebraic sum of the individual contribution of each source acting alone. So this is a statement. So when determining, that is when determining the contribution due to the particular independent source, we need to disable all remaining independent sources. We need to consider one source acting alone and disable other remaining independent sources. That is, all the remaining voltage sources are made zero by replacing them by short circuit, and current sources which are replacing by open circuit. And also it is important to note that if a dependent source is present, it must remain active during the process of superposition. So action plan, like how we can able to solve the problem, the procedure to solve the problem. So if you can consider a circuit which will be comprising of many independent sources, which means that if the circuit is having more than one independent source, in that case, only one source is allowed to be active. One source is acting alone and rest of the sources will be deactivated. That is nothing but off. If there is a voltage source, that is nothing but to deactivate voltage source, the voltage source is replaced by short circuit, and to deactivate current source, the current source which is replaced by open circuit. Then you need to find the response that will be obtained by applying each source one time, then added algebraically to obtain the solution. So this is how you need to remember the superposition theorem. So let me take you a simple example now. You can see, find the current flows through 6 ohm resistor using principle of superposition, a simple problem. So you need to find this current flows to 6 ohm. So you can see now there are two sources. In this circuit, it is having two sources. The first source is voltage source, that is 6 voltage source, and also a 2 ampere current source. Okay. So now you need to consider any one source acting alone. Then you have to deactivate other source. For example, you need to find current flows to 6 ohm resistor. So in that case, what you are doing now? So here, let me consider. It will be having two cases because it is having two independent sources. I'll consider case one. I'll consider 6 voltage source acting alone. 6 volt source acting alone. So if it has to act alone means you have to make other voltage source or current source as zero. So you'll be having 2 ampere current source. Therefore, 2 ampere current source becomes zero. That is nothing but open circuit. So now how that circuit which looks like? Then current flows to the 6 ohm, that will be act as I dash. So you can see here the 6 ohm resistor which you can consider now. 6 ohm resistor, the circuit will be like this. 6 voltage you are considering, that is 6 voltage is acting alone. You'll be having 3 ohm resistor and you are having 6 ohm resistor, and the 2 ampere current source becomes zero. So that current source is open circuit. So whatever the current flows to the 6 ohm resistor, now I can consider that as I dash, or else I1 or I2, whatever you can consider. and one more resistor is a 3 ohm. So now we need to find I dash. To find I dash, you use any network reduction techniques to find I dash. So it is a simple circuit. I can easily get the I dash by applying Ohm's law. I dash is given by total voltage V divided by R equivalent, whereas a V is a 6 volts. R equivalent, these two are in series now. That's nothing but 6 divided by 9 amperes. 6 divided by 9 amperes. 6 by 9 amperes is nothing but 0.666. 6 divided by 9 is nothing but 0.667 amperes. 0.6667 amperes. So this is the first case. Similarly, you have to do it for case 2. So what is case 2 now? The case 2 is you already consider the voltage source alone. So now you need to consider current source alone and you have to make voltage source as 0. So now we'll consider case 2. Consider only 2 ampere current source alone. Therefore, 6 voltage source becomes 0. That is nothing but short circuit. 6 volts is replaced by short circuit. Therefore, the circuit which looks like this 6 volts is replaced by short circuit. Short circuit, and there will be 3 ohm resistor, and you're having 6 ohm resistor, 6 ohm resistor, and you're having current source. You're considering the direction of current source. You know now this is upward 2 amperes. 2 amperes current source. So now this current is dividing. So now current flows through the 6 ohm is nothing but I double dash according to the statement of superposition theorem. So you can easily find I double dash now just by applying current divide rule. Then apply current divide rule, can easily get I double dash. Therefore, I double dash is given by total current is 2 amperes, it is flowing towards total current into opposite resistor of this is 3 ohm into 3 divided by sum of these two resistors, that is 6 plus 3 is nothing but 9. That is nothing but again 6 divided by 9, that is equal to 0.6667 amperes. So now we got to know the value of current flows to the 6 ohm by considering 6 volts once and 2 amperes once. So now we need to find the total current I is given by I dash. You need to add the current which will be getting from both the cases, I dash plus I double dash. You know the values of I dash and I double dash, 0.6667 plus 0.6667. You get I equals 1.3, it seems. 0.667 plus 0.6667. 1.3334. You can get current as 1.3334 amperes. This is your current value. You can take a screenshot. It is very easy to understand the superposition theorem. If you want to understand in Kannada, so ಇವಾಗ more than one source ಇದ್ದಾಗ ಏನು ಮಾಡ್ತೀರಾ, one source ನ ಇಂಡಿಪೆಂಡೆಂಟ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ, ಉಳಿದಿರೋ ಸೋರ್ಸಸ್ ಎಲ್ಲ ಝೀರೋ ಮಾಡ್ತೀರಾ. ಇವಾಗ ಈ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲಿ ಒಂದು ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಇದೆ, ಒಂದು ಕರೆಂಟ್ ಸೋರ್ಸ್ ಇದೆ. ಸೊ ಅದಕ್ಕೆ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ನಾನು ಏನು ಮಾಡಿದ್ದೀನಿ, 6 ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ. ಅವಾಗ 2 ಆಂಪಿಯರ್ಸ್ ಕರೆಂಟ್ ಸೋರ್ಸ್ನ ಏನು ಮಾಡಬೇಕು, ಝೀರೋ ಮಾಡಬೇಕು. ಕರೆಂಟ್ ಸೋರ್ಸ್ ಯಾವಾಗ ಝೀರೋ ಆಗುತ್ತೆ, ವೆನ್ ಇಟ್ ಈಸ್ ಓಪನ್ ಸರ್ಕ್ಯೂಟ್. ಅದಕ್ಕೆ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ 6 ವೋಲ್ಟೇಜ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ, 2 ಆಂಪಿಯರ್ ಕರೆಂಟ್ ಸೋರ್ಸ್ನ ಝೀರೋ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. ಸರ್ಕ್ಯೂಟ್ ಈ ಥರ ಆಗುತ್ತೆ ಅವಾಗ. ಸೊ ಅವಾಗ ಕರೆಂಟ್ ಫ್ಲೋಸ್ 6 ಓಮ್ ಏನಾಗುತ್ತೆ, ಐ ಡ್ಯಾಶ್ ಆಗುತ್ತೆ. ಸೊ ಸಿಂಪಲ್ ಸರ್ಕ್ಯೂಟ್ ಇದೆ, ಓಮ್ಸ್ ಲಾ ಅಪ್ಲೈ ಮಾಡಿ ಐ ಡ್ಯಾಶ್ ಫೈಂಡ್ ಮಾಡ್ತೀರಾ. ನೆಕ್ಸ್ಟ್ ಏನ್ ಮಾಡ್ತೀರಾ, 2 ಆಂಪಿಯರ್ಸ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಾ. ಅವಾಗ 6 ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಏನಾಗುತ್ತೆ, ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಆಗುತ್ತೆ. ಅವಾಗ ಸರ್ಕ್ಯೂಟ್ ಈ ತರ ಆಗುತ್ತೆ. ಸೊ ಕರೆಂಟ್ ಫ್ಲೋಸ್ 6 ಓಮ್ ಏನಾಗುತ್ತೆ, ಐ ಡಬಲ್ ಡ್ಯಾಶ್ ಆಗುತ್ತೆ. ಸೊ ಸಿಂಪಲ್ ಪ್ಯಾರಲಲ್ ಸರ್ಕ್ಯೂಟ್, ಕರೆಂಟ್ ಡಿವೈಡ್ ರೂಲ್ ಅಪ್ಲೈ ಮಾಡಿ ಐ ಡಬಲ್ ಡ್ಯಾಶ್ ಸಿಗುತ್ತೆ. So need to add I dash and I double dash to get the total current that flows to 6 ohm if you are applying the superposition theorem. So if you're having any doubts regarding this, you can feel free to write in the comment box. If you really like this video, please do subscribe and share maximum. All the very best. Have a nice day. Thank you.